Welcome to the DIY Honda Garage channel. The DTC P0116 indicates an issue with the engine coolant temperature ECT Sensor 1 circuit, specifically related to the sensor's range or performance. The ECT sensor plays a crucial role in managing engine performance by providing real-time coolant temperature data to the Engine Control Module, ECM. This information is essential for adjusting fuel injection, ignition timing, and other critical parameters to optimize engine efficiency and emissions. The ECT sensor is typically located near the thermostat housing or in the engine block, making it integral to the engine's cooling system. Diagnosing issues with ECT Sensor 1 is vital, as it can lead to poor engine performance and increased emissions if left unresolved. The vehicle's onboard diagnostic system flags this trouble code when the readings fall outside predefined thresholds, indicating potential sensor failure or wiring problems. The ECT sensor is responsible for monitoring the temperature of the engine coolant, providing critical data to ensure optimal engine performance. Located near the thermostat housing, it detects coolant temperature and sends this information to the Engine Control Module, ECM. The ECM uses this data to regulate various engine functions, including fuel injection and ignition timing, which directly influence the engine's efficiency and performance. When the ECT sensor fails or the wiring is compromised, it may result in a DTC P0116 being triggered, indicating that the sensor's readings are outside of acceptable range or performance parameters. Understanding the ECT sensor's role is essential for diagnosing issues related to engine overheating or underperformance. Accurate functioning of the ECT sensor is crucial for maintaining vehicle emissions within regulatory limits. The DTC P0116 can arise from several potential causes, including a faulty ECT sensor, wiring issues, or poor electrical connections. A malfunctioning ECT sensor may present inaccurate temperature readings, leading the ECM to miscalculate engine parameters. Wiring problems, such as shorts, breaks, or corrosion, can interrupt communication between the ECT sensor and the ECM, producing erroneous readings that trigger the DTC. Additionally, loose or corroded connections at the sensor or the powertrain control module, PCM, can contribute to intermittent failures. Each of these causes can significantly affect engine performance and emissions, making it paramount to investigate all potential issues thoroughly. Recognizing these causes helps in pinpointing not just the immediate problem, but also any underlying electrical system weaknesses. Symptoms associated with DTC P0116 typically include poor engine performance, increased emissions, and erratic coolant temperature readings. When the ECT sensor is malfunctioning, the ECU may receive misleading data, leading to incorrect fuel mixture adjustments. Consequently, drivers may experience sluggish acceleration, stalling, or rough idling, which can be frustrating and potentially hazardous. Increased emissions occur as the ECM may not adequately adjust fuel parameters, failing to meet environmental regulations. Furthermore, drivers may notice that temperature gauge readings fluctuate unpredictably, making it challenging to gauge the engine's actual operating temperature. These symptoms highlight the importance of quickly diagnosing and addressing ECT sensor-related issues to maintain vehicle reliability and compliance with emission standards. In the first step of troubleshooting DTC P0116, start by turning the vehicle ignition to the on position without starting the engine. This allows the Honda Diagnostic System, HDS, to access the ECT sensor data. With the HDS, check the parameters displayed for ECT Sensor 1. Specifically, you want to note if the current conditions for this sensor are above 176 degrees Fahrenheit, 80 degrees Celsius. This threshold is crucial. If the sensor indicates it has exceeded these values, it suggests that the sensor may be functioning correctly at that moment. Document the real-time value of ECT Sensor 1. If the readings meet or exceed the threshold, proceed to the next step. Otherwise, you need to investigate potential reasoning as to why the readings are off, possibly indicating an issue with the sensor or its connections. For the second troubleshooting step, first note the current ECT Sensor 1 value in the HDS data list. Following that, start the engine and hold the engine speed at 3000 RPM without any load. In automatic transmissions, ensure the gear is in park. For manual transmissions, ensure it's in neutral. This step helps to mimic load conditions and allows the engine to reach operational temperatures while also triggering the radiator fan. Subsequently, observe the ECT Sensor 1 readings in the HDS data list again. If the temperature registered by the ECT sensor changes by 18 degrees Fahrenheit, 10 degrees Celsius or more, this suggests the sensor is capable of responding correctly under dynamic conditions. Should this occur, it indicates a potential intermittent fault, and follow-up checks for loose connections at the ECT sensor and the PCM would be necessary. If the readings do not change, it indicates a failure, and replacement of the ECT sensor is required. The third troubleshooting step involves verifying the ECT sensor's performance after allowing the engine to cool completely. Start by turning the vehicle to the off lock mode, and then open the hood, letting the engine cool down for approximately 3 hours. This cooling period is essential for obtaining a true reading of the sensor's baseline performance in lower temperature conditions. Once the 3-hour mark is reached, turn the vehicle ignition back to the on position without starting the engine. Use the Honda Diagnostic System HDS to check the current conditions for ECT Sensor 1 again. Just like in Step 1, confirm whether or not the ECT Sensor 1 reading changes by 18 degrees Fahrenheit, 10 degrees Celsius or more. If it does, this signifies that the sensor is likely functioning intermittently, and electrical connections should be checked. A failure to change indicates the sensor is faulty and should be replaced to restore accurate readings and efficient vehicle operation. After completing repairs for DTC P0116, it is vital to conduct a final verification process. Begin with a test drive of the vehicle under various operating conditions to ensure that the ECT sensor and the system work correctly. During the test drive, monitor the coolant temperature readings and ensure they remain consistent with expected values throughout the drive. After the test drive, record all diagnostic data, checking for any reoccurrence of the error code P0116 or related DTCs. This compilation of data helps confirm not just the repair's success, but also the vehicle's overall functionality. Lastly, clear any diagnostic trouble codes, DTCs, stored after confirming that the repairs were effective. This clearing process resets the vehicle's diagnostic systems, allowing for the monitoring of ECT sensor performance in future drives. Preventive maintenance is crucial in avoiding the occurrence of DTC P0116 in the future. Regular checks of the ECT sensor should be conducted, ensuring it operates within specified thresholds to prevent issues before they escalate. It's also beneficial to inspect the wiring and connectors associated with the ECT sensor frequently. Signs of wear or corrosion can lead to performance issues, so addressing these conditions promptly can help maintain continuous correct operation. Additionally, after any significant repairs, it's advisable to clear the DTC history to establish a fresh diagnostic baseline. Keeping the systems clear of erroneous codes allows for more accurate diagnosis should any future problems arise. Following these preventive measures increases the vehicle's reliability and performance longevity, ensuring smooth operation over time. In conclusion, understanding the role of the ECT sensor is fundamental in diagnosing DTC P0116 effectively. This sensor is vital for regulating engine temperature and performance, significantly impacting overall vehicle efficiency and emissions. Early identification of symptoms associated with ECT sensor failure, such as poor performance and erratic readings, can lead to timely interventions. Following the troubleshooting steps detailed in this guide will allow technicians to systematically diagnose and correct the issues accurately, either by repairing or replacing the ECT sensor and ensuring solid electrical connectivity. Finally, engaging in preventive maintenance is paramount to prolonging the life of the sensor and the overall engine management system. By adhering to these best practices, vehicle owners can preserve the integrity of their Honda Fit's engine, improving reliability and performance over time. Please like and subscribe to the channel. See you next time.